This is continuing the first part of lesson 1.1. And so we've gone over the vocabulary for terms, coefficients, constants, like terms, expressions. And so we're going to fill in this table. So it says for each expression, so make sure you understand what that word means. So each of these, 11 through 15, is an expression. We are going to step 1, can the expression be simplified? This is a really important step and question to ask yourself, because if it can, then you need to simplify it before you do step 2. If it cannot be simplified, then you're going to go to step 2. And so we'll talk about that as we see some examples. In step 2, you will identify the term, the coefficients, and the constants in the expression. So let's start with number 11. It says 10v to the third minus 7v. So the first question is, can it be simplified? If you are subtracting, which we are, you must have like terms. So are these like terms? So you can go back to the previous section and see if those would be like terms. So think of my apple and apple pie example. They're not like terms, so I cannot subtract them. Some people mistakenly will say, oh, that's going to be 3v to the, second or third or first or something. And that's not right. They're not like terms. You cannot combine them. So I'm ready to do step 2. So step 2, it says identify each term. So I've got one expression with one term. And then the second term is not just 7v, but also includes the sign. So I'm going to say 10v to the third is one term, comma, and then negative 7v to the third. So you want to make sure you get the sign with it. Now, if it's a positive, you don't need to write the plus. But if it's a negative, you do have to write the negative. Okay, the coefficients are the number parts of those terms. So 10 would be one, and negative 7 would be another. So you can see on a test, if I was to ask you what are the coefficients, if you just write 10 and 7, you can see how that's going to be wrong. You can see on the terms part, if you just write 10v to the third and 7v, whoops, that shouldn't be to the third, sorry, 7v, that's going to be wrong because you have to have the negative in there as well, so you have to get the negative as part of it, so pay attention. And then the last one, the constants, there's no constants in this one. Now there's always a plus 0, but we don't count that, so we're just going to say on that one, we're going to say that there are no constants. Okay, number 12. Let me erase this other stuff so it's not distracting. I'm going to actually scoot this up so we can have some space to look at that. We look at this expression. This looks like something we saw at the beginning of the lesson with, I need to do some stuff with that. This is something that definitely needs to be looked at. So if I look at simplifying, think about what we've done before with distribution. So 2 times 3, 2 times x. You've done this before, so this is a good review. Plus, and then x times 1, and x times negative 4x. So it's a positive x times a negative 4x, so it's negative. There is a 1 right there, so 1 times negative 4. And an x times x is x to the second power, and then plus 5. Now this is a little more complicated level, but it's still something that you've done before with distribution, so just bringing that into review. Now look at this. Do you see like terms anywhere? I see these two are like terms. I also see that these two are like terms. So I'm going to rewrite that. So I'm going to write the negative 4x squared. And so that takes care of that. Don't forget the negative on it. Then I've got 2x plus 1x is 3x. And then 6 plus 5 is 11. So actually what this number 12 is, it's actually that. Now that's going to change things because when I go to write my terms, that's going to be a whole lot different than if I didn't simplify that. So in my terms, I'm going to have negative 4x squared, comma, 3x, comma, and 11. My coefficients are the number part of the term, not the variable part. And a coefficient is not a constant. So I'm going to have negative 4 and positive 3, but not 11. 11 is not a coefficient. It is a constant. So you might want to pause this and go through all of those steps and make sure you understand what I did there. Okay, number 13. Again, I'm going to write that down here and just give myself a little bit of space to work. 9n plus 12 minus 8n minus 7. Do you see any like terms? I see 9n minus 8n. So 9 minus 8 is 1. So it's just n. Now you can write 1n. I don't usually write a 1 in front because that's just understood. And I don't feel like I need to write extra. and then 12 minus 7 is 5. So what this term is actually, it's actually n plus 5. That's what we're talking about on number 13. So the terms would be n and 5. The coefficient would be the number in front of the n, which is 1, and the constant is 5. So a number can't be both a coefficient and a constant, remember. Okay, number 14. I look at that and I've got two terms in that expression. I've got one term and two terms. And they're not like terms because the one has x squared and the other one does not. So I can't add them together in any way. So I'm ready to just go ahead and say that the terms are 3x squared over 4 and 5. The constant should be obvious that it's 5. Let's talk about the coefficient. If I have this, and you might want to write this down somewhere, that is exactly the same thing as saying this. And it sometimes helps to write it that way because now it's very obvious that my coefficient is 3/4. So remember that. We'll see a lot of fractions that we'll have to deal with. Okay, and then number 15, I look at this and I've got x squared, and then x. I can combine those x squared. So I've got 1x squared plus 2x squared. That's 3x squared, and then minus 3x. So this is what I'm talking about in number 15. So my terms are 3x squared, comma, negative 3x. My coefficients are 3 and negative 3, and there are no constants. Okay, the last part of this lesson, we're going to do some comparisons. And so number 16, it says, is the expression 6m plus 10 the same thing as 2 times 3m minus 5? So the way that we tell that is we just make sure both of these are simplified. So 6m minus 10, there's nothing I can do with that. 6m minus 10, there's not like terms or anything. Now the 2 times 3m minus 5, I can distribute. So I'm going to have 2 times 3m, so 2 times 3 is 6 times the m, and 2 times negative 5 is negative 10. So this is the same as that one, so it's going to be yes. Now as far as the explain part, all you have to do is show what you did. So I could have just shown my work down here and written 6m minus 10 equals 6m minus 10, and that's showing my work or explaining. In math, when we explain, a lot of times what we do is we're just writing out equations and expressions and operations. So in math, explaining doesn't necessarily take on words. It can, but sometimes it's just writing out what you're doing. And so in this class, I'm going to expect you to be writing out what you're doing because that's your explaining, you're justifying. Okay, the number 17, it says, is the expression 12v equal to 7 plus 5 in parentheses times v? So let's take a look at what we can do. We can take the 7 plus 5, let me write that down here. So 7 plus 5 times v, order of operations, say do what's inside the parentheses. So I'm going to say 12 times v. That's 12v. And that's equal to 12v from up there. So that's my explanation, and I'm going to say yes. Okay, let me erase what I've got here so that we don't get distracted. Number 18, is the expression 12v equal to the expression 7v plus 5? So I want you to pause the video and I want you to write yes or no, commit to it, and then explain why you think, and then turn on the video and see if you were right. Okay, on this one, before saying what I'm going to say, if I look at 7v plus 5, the first thing I want you to notice is these are not like terms. Since they're not like terms, I can't do anything with it. I cannot add them together. So 7v plus 5 is just 7v plus 5, and that's not equal to 12v. And so the answer is no, and that's my explanation right there. Number 19, I want you to do the same thing again. I want you to commit to a yes or no, and I want you to write it down and then write out why you think. And then you're going to turn the video back on, and you might be right and you might be wrong, but I want you either way to understand what the correct answer is and why. And you're welcome to change your answer after you see the explanation, but it probably would be good to keep the wrong answer. If you have the wrong answer, it's good to keep the wrong answer and then just maybe like cross it out or something and just write the correct thing below it, because sometimes making mistakes is a really valuable lesson. So on number 19 is the expression 4 times 3 to the x equal to 12 to the x. So I want you to pause and think about it. I want you to commit to a yes or no, write it down, and then I want you to explain why you think your answer is right. Okay, now remember that regardless of what you came up with, I want you to listen to the explanation, and you're welcome to write it down. And if your answer is wrong, that's okay, because you're learning something here. Okay, if I look at 4 times 3 to the x, first of all, I want you to notice we are multiplying. And so when you multiply, you do not have to have like terms, okay? Like terms are not necessary when you multiply. You can multiply anything you want. You can multiply 3x times 4z and get 12xz. All right, so you can do that, okay? However, look at what this is. That's not 4 times 3x. It's 4 times 3 to the x. Whoops, to the x. That's different, okay? So that's if I have something like 4 times 2 to the third power. I can't just say, well, I'm just going to do 4 times 2, and that's 8 to the third power, because 8 to the third power, check that out, that's a pretty big number. Okay, if I do 2 to the third first, like the order of operations says I need to, that's 2 times 2 times 2, which is not 6, it's 8. So 4 times 8 is 32, which is a much different number than 400 or 512. So when I look at 3 to the x power, that's not the same as 3x. And so based on the example I just saw, I cannot take 4 times 3 and say that that's 12 and then just throw to the x power on the other side. Order of operations says I need to do this first, and since I don't know what x is, there's nothing I can do. So I'm going to have to say that that's just 4 times 3 to the x power, and that is not equal to 12 to the x power. For my explanation, things that I've heard in the past is students can say, well, if I let x equal 2, I can see that 12 to the second power is equal to 144. 4 times 3 to the second power is 4 times 9, which is 36, and so obviously they're not the same. I've had students explain that order of operations say that exponents have to go first. Okay, but you're going to see a problem like that here and there, and you need to remember that 3 to the x power is not the same thing as 3x. So be really careful when you write exponents and when you read them, okay? Okay, so the next thing is you're going to go ahead and go to your homework assignment. You are welcome to have your notes out during your homework assignment to help you go back and look at examples. When you do your homework assignment, you need to show your work. Okay, especially if it says show your work, but even if it doesn't say show your work, there should be something besides just an answer. If I see a homework assignment with just an answer, that doesn't look very good for you. When you are done with your homework, then you should have access to an answer key. If you don't, please let me know that you don't have access. You must be logged in with your school email. That's the only way you're going to have access. So you can't email me from your Gmail address or your Hotmail or your parents' email or whatever. It has to be your student email account, and that's how you're going to have access. But you can open up the answer key and then you can grade your homework. You're going to go through and make sure you got everything right. If you didn't get it right, what happens if you get something wrong? Well, if you get something wrong, there's a lesson to be learned from that. Okay, so we make mistakes and we learn a lesson. So I want you to learn the lesson, and I want you to go, oh, wow, I did that wrong. How come I did it wrong? Look at my work, compare it to your work. Once you feel like you understand why you got it wrong, you're welcome to change your answer if it makes you feel better. You can say number 3, and if it was 5 plus 2 times 3, and you wrote that was 21. Okay, first off, you didn't show any work. But secondly, when you look at the answer key, you'll see that is not what I have. So let's say over here, I'm going to write what I have on the answer key. So I'll have the problem, and on the answer key, I would have something like this. I'd have 5 plus 6, and then that's 11, like that. And so you can look at what's on the answer key, and what I would want you to do then is I would want you to go, oh, okay, so I'm going to mark this wrong. You're not going to lose points for it because the way I grade isn't like that. But I want you to mark it wrong, but then you can write what I have and say that that's 6, and then you can, 6, and then you can say the answer is 11. And if you're doing that in a red pen or a different colored pen, then it's easy for me to see that you had the wrong answer, but you changed it. So I'm looking at that as you learned a lesson. And so you are welcome to change your answers on your homework, because the homework is about practicing and learning. And so when you're done with your homework and you've graded, okay, so part of the requirement is that you grade it, complete it first, grade it, and then you're going to submit. Now, when you submit your homework, and we'll practice this in class the first couple of times, you need to make sure that you have one document that has all the pages. So if there's 2 pages, I want to only have to open one file. So we'll talk in class about ways to do that, but I also need them to be clear so that I can see what you wrote, and I can correct things. If I want to write you a note on there or something, I can say, oh, hey, look at this. Notice what you did right there, and I can write you a note on that. Or I don't do that very often, but just in case I wanted to, I want to be able to see what you did. When you've submitted your homework assignment, you're going to hold on to your hard copy. So you should have a binder that you're putting your hard copy in, and so if there's ever any question about it, you have it there. You also have it there to look at later if you're doing some problems down the road that look something similar. You can look at that. So your homework and your notes are there for you to learn from and to use, and you can do that anytime except for on a quiz or a test. And if you ever have any questions on anything, make sure you ask me.